Hello, my name is Dr. Gleisner and I'm talking about Group 1 chemistry. And the specification says the elements in Group 1 of the periodic table are known as the alkali metals, I've said that before, and have characteristic properties because of the single electron in their outer shell. So on the periodic table you can see that the Group 1 metals are all down here. Hydrogen is also in Group 1, but it's not a metal, at least not until it's frozen. Students should be able to describe the reactions of the first three alkali metals with oxygen, chlorine and water. So the first thing that we're actually going to do is we're going to state that in Group 1 the reactivity of the elements increases going down the group. So I am going to focus on the first three, lithium, sodium and potassium. The reactivity increases as you go down the group. Why is that? Well, if you look at the electron configuration, for lithium it's 2,1, for sodium it's 2,8,1, and for potassium it's 2,8,8,1. And what we know is that the single outer electron is further away each time from the nucleus. That means it's actually easier to detach it from the sodium. Note please that I haven't drawn the full shells in the middle. So there would be 1 and here would be 2. So the good news is that although it appears you have to learn 3 separate reactions, one with oxygen, one with chlorine and with water, by the time that you've got one of them under your belt, the other ones just need to be substituted with the corresponding metal. So let's say you've got lithium, and lithium reacts with water to make lithium hydroxide and hydrogen. So now, if you want to substitute sodium, so it's no longer lithium of interest, it's sodium, then all you've got to do is replace lithium with sodium. Now, in a word equation, that is fairly straightforward. But how do you do that? How do you do that in a symbol equation? Well, okay, so lithium is Li, water is H2O. So the first thing that we've got to do is balance this equation, lithium hydroxide plus hydrogen. You will see that on the right-hand side we've got 3 H's, but we've only got 2 H's on the left-hand side. So we're going to invest in one more water. Now we've got 3 H's on the right, and the way that we get to 4 is by investing in another lithium hydroxide. So now we've got 4 H's, we've got 2 O's, and what you can see here is that we've got 2 O's from the water, and you've got 2 Li's, and we just need to put a big 2 in front of that. So while you can't adjust the little numbers, you can adjust the big numbers. So if I want to do the same thing with potassium, just as an example, then all I have to do is copy it, but substitute the potassium for the lithium. Everything else stays the same. So let's see what happens with oxygen. Sodium plus oxygen gives you sodium oxide, and that's pretty much it. So we need 2 sodiums, because each sodium is capable of giving 1 electron away, and if you don't remember that, remember it's a group 1 metal with 1 outer electron, where oxygen is in group 6, so that's in group 1, let's give that a Roman numeral, that's in group 6, and overall these should add up to 8. But you see that these only add up to 7. So how do I get 8? Well, I use 2 of the group 1 metals, and now I've got 8. So 2 of the group 1 metals and 2 oxygens gives me sodium oxide. Now you have 2 oxygens on the left-hand side and only 1 on the right-hand side, you can do two things. Either you can halve the oxygen, the O2. If you don't like that, you simply double the amounts of sodiums that you have. Et voila. And now you've got 2 Na2O, because you've got 4 sodiums on the left, 4 sodiums on the right, and 2 oxygens on the right as well. If I wanted to do this with potassium, what do? Well, same as before. I simply substitute potassium into the equation. And of course the same for lithium and the same for cesium. What about the reaction with chlorine? Well, let's pick on lithium and let's react that with chlorine. Chlorine is Cl2. That's chlorine. So lithium chloride is, lithium is in group 1 and chlorine is in group 7. So in order to make 8, I just need the 1 lithium. But the problem is that I've got 2 chlorines on the left-hand side. Now again, I can simply say 1/2 chlorine 2, which gives me 1 chlorine. Or if you don't like this, I can double the amount of lithium. And that means I get 2 lithium chlorides. If I want to replace that with sodium, for example, I simply copy that. And it's exactly the same. Sorry about the L again. And it is exactly the same chemical equation, except for the sodium replacing the lithium, and the same for cesium and the same for potassium. The specification also says students should be able to explain how properties of the elements in group 1 depend on the outer shell of electrons of the atoms. Now, there are a couple of properties which you need to be aware of. So, lithium, sodium, potassium get softer and easier to cut as you go down the group. They also become more dense. The other thing is that boiling points and melting points actually decrease. So boiling points and melting points decrease, and they are quite easy to melt compared to iron and copper and silver and gold and transition metals in general. The density is not quite as easy to explain because it actually hits a little snag around potassium. So from lithium to sodium to cesium and rubidium, it's fine, but potassium actually has a slightly lower density than sodium. But there are 2 factors which change down the group at the same time. The way that the atoms pack in to the same space stays the same, but you have the volume increasing as you go down, and therefore you've got fewer atoms in the same volume, but you have the mass of the atoms also increasing, and that is sort of a contradictory trend, or those 2 trends are opposing each other. So when you are given a trend, then you should always look at the outer electron. What's the outer electron doing? That's important for reactivity. So going down the group, the outer electron gets further away, so it's easier to lose it. It's not just given away, of course, it has to be taken away. And the other trend is towards more softness, towards more density, and towards a lower boiling and melting point. Please like and subscribe and let me know of any questions you'd like me to cover in the comments.